Assalamu alaikum and welcome to again another episode for Programming Fundamentals. In the last part, we have discussed in detail the while loop, the for loop, and the chapter number 4 slides. We discussed in much detail. We did some examples also. We discussed about the for loop. We discussed how the initialization was done, the for loop header, the conditions, the increments, the while loop. We have discussed it in the online class, but in the last lecture, we again discussed it. We see the difference between the while loop and the for loop and how this incrementing operator was there. We also discussed in chapter number 3 some of the examples over there, some the rectangle, printing a rectangle, the nested for loop over there. Today we are going to complete chapter number 4 over here, and just to give a little teaser from the last one, what we have done in the last one. The last few topics which we did at that time was this, that uh, the scope of the variable was one of very important topics, and this is one of the important things which we normally as programmers we do this mistake, that the variable, if it is defined inside, sorry, if the variable is defined inside this for loop over here, so of course this can only be addressed inside the for loop. But if this int I was defined beyond the for loop or above the for loop, then of course then this can be used inside the for loop also and outside the for loop also, just like this one. So int I is equal to 1 here, that initialization thing is gone. So I is equal to 1. So this is just a semicolon over there, the condition statement, and then the post increment operator, which is I plus plus or plus plus I, you can call it. So here I still exists, so you can use it outside the for loop. So the for loop has this body. This is printf over there is the body of that for loop. So this was very important, the scope of the control variable. Now this topic will again come in when we're discussing functions, because whenever a variable is initialized and declared inside a braces or inside a function or inside a loop or inside a set of commands, then it can only be used inside that thing. That's why the scope of that variable is limited to that. But if it is a variable which is being accessed in whole of the program, then that type of variable is called as a global variable. We will discuss this later on when the course progresses and we are moving on towards the functions and all that stuff. We will discuss this in detail, but the scope of variable is something very, very important. So be very careful. If you want to address that variable outside the for loop or even the while loop, then please have it as a global variable, or outside the initialization should be done before that, or the declaration should be done. Then very important thing, I told you that if you're not using that equal to sign over there, then of course this is just less than 5. This one is less than and equal to 5. So of course when it's going to start from 1, so 1, 2, 3, 4, 5, all 5 are going to be printed. But when this is this one, only 1, 2, 3, 4 will be printed, because 4 is less than 5, but 5 is not less than 5. So this condition will not be met, and this printf will not be printed over there, so it will be missing a 5. So this was one of the errors which is normally done. We did this one, the for statement, that was we have already done it: initialization, the loop continuation condition, the increment, and the body statement or the simple statements over there. Remember, 2 semicolons are required. Even if your initialization is being done outside the for loop, still you need to put this semicolon and this semicolon always over there. So the loop body will not execute all the programs, the skips to the next statement if these 2 semicolons are required. So this is very important. Then we talked about the infinite loops also. I told you as example also that on your Windows command you have to use the control plus C. If you're on a MacBook, then you have to use the command plus C. So hold control and press C. This actually breaks that infinite loop, because here just for example, int I is equal to 1, and here you're not doing nothing with the I. So you have forgot it, or you have not done anything with the I. So the loop will always be printing I, and that I will be 1, 1, 1, 1, 1, 1 will be printed continuously, and the loop will never be broken. So if you want to break that loop, then you have to use the control plus C option over there. Then of course an option can be there, and I did it as an example as well, that instead of incrementing it, you have decreased it over here. So instead of having the value of I going on from 1, 2, 3, 4, and 5 and so on, so it's now going in the negative direction. So this means 1, then 0, then -1, then -2, and it will continue to go on. So this will be again printing I every time this, and that will be a never ending loop or infinite loop. So you have to break this loop over there by control C, and this is a fatal error over there. Then we talked about this incrementing and decrementing operator. We have already discussed this in the last lecture also. And now coming on to how the increment operators are being done. Now, up till now, we have been discussing that plus plus I was an increment operator, which was a post increment operator. Minus minus I is a pre decrement operator, or you can call it a post, actually not pre, actually it is actually a post over there. So you are having this one first of all added together a one value, but here this is count by one, count down by one, which means actually you are decreasing it by one. But if you want to do it by seven, supposingly you don't want the number to be incremented by one, you want to increment it by seven, then you can use this expression. So you are not bounded that you always have to use this as plus plus I. You can use an expression something like this. So now this expression actually becomes very important over there, which is equal to I plus equal to 7. So this is something very important. So every time in 7 is going to be increased. So what will happen? I will be having initial value of 7, then 7 plus 7 14, then 14 plus 7 21, then 21 plus 7 28, and then so on. This will go on up till the value of I becomes equal to 77. So 77 will be the last value that will be printed over there. But afterwards 77, because 77 plus 7 will then be 84. So that will never be printed because that is greater than this condition which is over here. Similarly, you can do it count down by 2 as well. So this can be minus 2 as well. So any operation can be done, not just this. We're not limited by plus plus I or minus minus I. You can write any expression over here inside this one, and you can find out anything. So you can do a count by 3 as well. You can do a count down by 11 or any number. Whatever you want to do, you can do it over there. So these three expressions or these three statements inside the forehead of your for loop, or the body of your is, so not the body, actually the forehead of the for loop, are always going to be having. So you are feel free to view anything. In fact, there is one example inside our let me just go on to the example. So over here, let's see, I have this let me just see if there is some example. Okay, I have an example over here. Let's see this example first over there. This is an example, and what is doing over there, int sum is equal to 0, initializing the sum. For loop is started, int number is equal to 2. So you're starting from 2, then number is less than or equal to 100. So this means it will go from 2 to 100, of course. And here number is equal to plus equal to 2, which means number will be added by 2 over there. So this means what is going to be added? 2, 4, 6, 8, 10, 12, 14, 16, 18, so on. So what you are doing, you are actually doing the even number sum for the first 100 integers. So what you are doing over there, you are doing a sum is equal to sum plus number. So this is actually exactly the same thing. I guess this is exactly the same as, so this is the same as I told you in the last one as well. So this is the same is equal to same as same plus sum plus number, sorry, not same, sum plus number. So this is same sum plus minus number. So when this loop breaks off, this will be run for how many times? Let's see over there. If I just run it, save it over here. So when I run it over there, uh, the sum is 2550. So this is actually the sum of the first, how many integers or how many even numbers? They are like 50 even numbers being added over there. Now you want to increase it to like something 200. So now this time, because in the first 100 integers, how many even numbers are there? Of course, half of them are even, half of them are odd. So this will be 100 of them. So when I run it, this time it will be 10,100 over there. So this is a sum of it. And you can even do this one for the odd numbers as well. So you start from 1. Let's say you start from 1 and you do it this time for like 100. So this time now you are adding the odd numbers. Let's see what is the answer now. This will start from 1. So 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, and this will continue to go on. So when I do this one, so you can see now the sum is 2500. And this is exactly the same as that one because you are exactly having the same thing. So this is 1 to 100. The odd number sum is 2500. And if you change it to even, you can have the even number added from the first 100 integers over there. So this number, this is actually the increment operator. This can be changed to 1, 2, 5, whatever value you want to do it. as been shown in the slides over there. You can even decrement it if you want to do it. So you can have the for loop started from a higher value and then go to 0 or something negative even, totally up to you. You can use any of these operators over there. And I guess it's the same exact thing which I've done just now. Sum of the even integers from 2 to 100, exact same thing which I done it over there. And this is, I have just shown you over here. This was for the odd numbers. Odd number sum is 2500. And if I just again make it back, let's say, let's save it and I run it over there. So this is 2550 over there. So the sum of odd numbers and even numbers is totally different. So this is the sum of even numbers over there, and the sum of odd numbers you can do it. So this is going to be 2550 as is shown over there in this example. I just run it over there. So this is a sum of even numbers over there from 2, 4, 6, 8. So it's totally up to you. Even you can do it for like 3. Let's say I want to have a number 3, and every time I want to add a multiple of 3. Okay, and now this is not actually a type of a number. I'm just doing 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. So now you can go it up till, it will go up till 99, because 99 will be the last number. It will be divisible by 3. So that will be 99, but when it will be again checking on for 99 plus 3, so this will never run. So this can be none over there, and the answer will be 1683. So you can do it for very different cases over there, totally up to you. You can change this expression over there, you can change the initial start over there, and something. One thing very important, let's say I make it equal to 100. Okay, I'm not doing the opposite of it. Let's say I do it the opposite of it, and now I am decrementing that number and I'm changing it to, so what I'm doing now, I am now decreasing the value of number, but I am still adding it. Now, what will be the answer? Should it be the same? Let's see. So when I do it, yes, the sum is still the same, which is exactly like shown over there. Let me go back over there. It's 2550. Why? Because previously what I was doing, I was starting the for loop from 1 going on up till 100, or from 2 I was going on up till 100. Now this time I'm going from 100 to 2. So I'm decreasing it, but this inside the body of my for loop, I'm just adding all those numbers. So answer will be exactly the same. Just the sequence is different. So otherwise the answer is exactly the same over there. So I hope this example is clear, and how this for loop, you don't need to always have +1 over there or just plus plus over there. You can have any number of increment inside the control variable. This variable, the number, is called as the control variable because this controls the loop over there, how many times it's going to run. Then another example, very important one, I guess this is also done in the examples. Let's just see over there what is happening. Let's go on the example part. I guess this is here. Yes, this one. So let's see this example first. What is happening over here inside the main loop? I have a variable which is double, which means the data type or the type of the variable is double. So that's why it's actually the principal amount. How many amount you are going to invest in your bank, or you are going to put in your bank account. So that will be 1000.0. So you have approximately $1000 or 1000 rupees put inside your bank account. The rate at which you are going to get an interest, that how much interest you are going to get it. Now this is actually 5%, because 5% is 5 divided by 100 in mathematics terms. So this is actually 5 divided by 100 is 0.05. So this is the annual interest rate over there. So every time you have deposited 1000, or supposedly you have deposited 100 rupees over there, so in 1 year you are going to get 5 rupees on it. Now since you have deposited 1000, the annual interest rate this time will be approximately 50 rupees you are going to get as an output over there. So this is the annual interest rate. But when this 5% amount is going to be added inside the principal amount, because you have deposited $1000 or 1000 rupees, after the first year the amount becomes 1050. So next year it will be 5% of 1050. For that calculation, the loop is going to be run. And for that purpose over here, let's first of all see printf. This is percentage for format specifiers are there, and it in this one string over there, then 21s over there, and then we have the year, you have the amount on deposit. Now what is this happening over there? What is this 21 and what is this 4 and what is this happening over there? Let's see first of all what is happening. I will tell you this later on, but let me just see over there. After this format specifier, you're just printing year and you are just printing a string text over there, and you have added a 4 and you have added a 21. Now these are actually going to print some spaces before this year and this word amount on deposit. I will just show you this example when I run this one, and this will be more clear to you when this is run on over there. Then inside the for loop, how you are going to calculate the amount on deposit for each of the 10 years. First of all, you have for int year is equal to 1. So you are having a variable year. That year is going to go from 1 to 10. So every time there is an year, 1, 2, 3, 4, 5, 6, 7, 8, 9 to up till 10. So this will go on up till 10 over there. At 11, this will, and every time you are having an increment of year. So this is a post increment over there for the year. And now here you are calculating the amount which will be equal to principal amount, that was $1,000, 1,000 rupees over there, multiplied by, now this is POW, and you've used this in your lab. POW is the power. Now this is being done by the math function. So again, you are including a math function, that is math.h over there, and this is a double function. Again, this is a function. We'll come back to this one in the next chapter. But here, this is a POW. This is a power function, and inside it, I have the first variable, that is actually the data going inside it, is 1.0 plus rate. What is rate? Rate is 0.05, which is actually 5%. So this means 1.0 plus 0.05 is actually going to be 1.05. So every time you are going to have one amount, you are going to have the year increased over there. So this will be 1.05 to the power whatever that year is going on. So every time you are going to have the power calculated, and you are going to multiply this one with the principal amount over there. And then you are going to printf year and the amount, which means the year variable, which will be 1, 2, 3, 4 up till 10, and the amount, which is every time going to be the specified year over there. And again, you have 4D, which is actually the specifier for this year over there. And then you have 21.2. Now 21 is for the spaces over there. I will tell you later on when this is printed. And 0.2 is for the double specifier. So this is going to be decimal digits up till 0.2 will be printed over there. Let's see first of all how this actually shows on, and then I will explain you a little bit more how this is going to be printed. So just run it. And okay, let me just increase it. So what is the working over there? You have year, and after year first, you have the amount 1050. Now what happens? 1050 already, because 1000 rupees was deposited initially. 5% is the uh, annual interest rate. So this means 50 rupees will be added. So after 1 year, the amount of money in your bank will be 1050 rupees. Then afterwards, again 5% will be added to the amount, which is now 1050, because you're not taking out anything from the bank. So this will be 1050 multiplied by 1.05. So just to do it, let me just open my calculator over there, and you can do this one. So I have 1000, and I multiply it by 1.05. So the amount is now 1050. If I now again multiply it by, let's say, 1.05, so now this is 1102, which is the same exact amount, and 50 because I'm having those extra. Of course, if you are in dollars, then of course this 50 cents are something important, but if you are in rupees, then whoever cares for this 50 paisas in Pakistan. But anyway, so after second year, the amount on deposit is this. After third year, the amount on deposit is this, because every time you are taking an interest, that is being added inside your original amount. So after 10 years, the $1,000 is now equal to 1628.89. And these are being printed over here by this printf statement inside the for loop body. Now, coming on to one thing, what is this 4s and 21s? 4s over here is actually, because year is a string. Year is a string which you are printing. 4 is actually telling you that when you are going to print it, let's see over there, this one is going to be printed, and there is going to be a space of 4 words over there. You can see over there, this is a space of 4 words over there. And then amount on deposit, there is going to be a 21 space over there from that value. So when this is going to be printed, this will be automatically added over there as 21. And then when you are going inside your printf statement, again this 4D is printed. So this is having 1, 2, 3 after 4. This is 1 is printed over there, and then 21.2. 21 is for the 21 values over here. This is the leading spaces over there, and then afterwards you have 1050.2, whatever that number of double, and then 0.2 specifies how many digits after a decimal are being printed over there. So let's say I change it to, let's say, 4, and just again run it. So now this time you will see that this changes to 0, 0, 0, 0, 0. So again, every time you are changing it over there, and you can change it to any value over there. Let's say I change this to 2. Let's say I change this to 2. And what happens now? Now you can see what has happened. Now, previously this one was at below R, the word R below, but now this is below E. Why this has happened? Because now it is printing after 2. So after the first and second. So it is printing at the second column over there. So this 2 is actually defining that after how many spaces or after how many your word is going to be printed over there. So I just make it back to 4, and now this will be, so this is just like arranging your data below a column. So now this looks better. So this is actually without any table or without any lines or something like that. You have arranged your data. So this percentage D over here, or just simply 4S and 21S, you are actually arranging all your data inside a column. Now, if I just change it to like some, let's say for 25 over there, let's just see what happens. The above line will be a little. So now this is exactly at the center. Why? Because 4 steps I have taken it beyond. So you can see now by using this S and S specifier percentage 25S, you are changing it from 25 points to that point. So you are changing it and moving it on your screen, how you are printing it over there. So I guess this example is clear to you. And of course, already you have used this math function POW over there. So 1.05 into year, whatever you are having, that one principal amount over there. And this is going to give you the amount every time over there that is being calculated over there for your year that is being calculated over there. So I hope this example is clear. And this is exactly the same example which is being shown over here in this one. So remember one thing, you are using this one power function, power x comma y. For this one, please kindly go to w3schools.com. I have already given you this website previously in the lab. I have already told you. So W3 Schools, let me just open that, w3schools.com. And the math function just for you people, C language, if you go click on the C language, and if you go in the references section, math.h, and inside math.h, you have a lot amount of functions. Here I'm using the power function over there, which is this one. If you click on this one, so you can see now you can print your percentage f. Now since I am not printing it over there, so this is just spread 2 power 8 over there. If you want to just try it, the example is here. So 2 raised to power 8, 2 raised to power 8 is 256. Of course, 3 raised to power 4 is 81, because 3 into 3 into 3 into 3, which means actually 4 times you are multiplying 3. And then you have 9 raised to power 0.5. 0.5 is actually the square root. So this means 9 square root will be 3, which is actually 3.00. And then you have 8 raised to power minus 1. Now, since minus 1 is actually going to be reciprocal over there, so that's why this will be 8. So 1 by 8 is going to be 0.125, which is exactly the answer written over there. And then you have 10 raised to power minus 2. So that's why this is 0.001, because this is the square root of 10 in reciprocal over there. Plus, if you want to add the, by default you can see 1 2 3 4 6 are already every time printed. You want to change that thing to, let's say, 0.3, and you again run it. This will take some time because this is an online compiler taking the services from W3 Schools. So now you can see, because I have written it 0.3 or just simple 0.3, so this will be having only 3 significant digits after the decimal over there. So you can see this is just 3 significant digits. You can do it for the everything. Please kindly use this and all these functions over there. These functions are something very important, and all these functions will be usable in this course as this course goes on, and all these functions will be used a lot, especially when you are going to have a calculator or some functions being used over there. So these will be much important, so on. Next, coming on, again, the answer, I guess the compound interest output, just like I showed you in the example, is there. So kindly try to do this example over there. And same thing, year one, 1000 multiplied by 1.05, that is 1050. Then 1000 multiplied by 1.05 2 over there, then raised to power then thing. Exactly, this is actually some nomenclature is wrong over there, but exactly the same thing which is being done every time you are being multiplying it. So this is 1.05 multiplied by 1.05, and then this time at year 10 this will be 10 times being multiplied over there. So every time you are multiplying the principal amount by 1.05 by 1.05, so after 10 years the principal amount is being multiplied by 1.05 1.05 10 times over there. So the output final is 1628 8.89, which is exactly the item over here in this one. So you can see, since I have given it four decimal displays significant digits after decimal, so this why this is 8946. In the slides, this is actually 89 just over there. So this is actually a very important example using the power function, or the x to raise to power y function over there. So then, of course, coming back to the same thing which I've already told you, that percentage f is the floating point number. 21 field width, this is the total space used over there. So 21 is the field width over there. 0.2 is for the precision, how many decimal digits afterwards you have after the decimal. And by default, if you are not going to specify this 21, then it is always right aligned. So spaces will always be, so by default, it is right aligned. So spaces are always on the left. So if you don't give any 21 value, you just leave it empty. So that will always be right aligned over there by default over there. Then afterwards, if you put some value 10 over there, as you have written over there 10, so that's why now this is 10 spaces after printing 123.50. So you can see over there when this is 10. Now, if I supposedly want to make it left aligned, if I want to make it left aligned over there, then use negative sign over there. So this negative 10, this will now make it left aligned over there. So you are having to have it separated from this one. And you try to do this one, right line and left line in your case on your examples. You already have the examples with you. The link is available in the details of this link also, or this video link as well. So can you try to use this left line and right line thing and confirm this value which is being shown over there? Already you are familiar with this 0.2 or 0.3, whatever you want to have two decimal places being printed over there. Then next thing, very importantly, which is the main important point of this today's lecture, is instead of using an if-else statement, which we did in the last lecture, that if it was an if this condition was true, then only this will be running. If this is not true, then it will go on to this one. Then it is true, then it will not be going to on this one. If it is also not true, then it will going on this one. If it is also not true, then it will going on this one. And similarly, if all of these are not true, then else afterwards it will print invalid over there. Now, this is a little tedious thing because every time you have to write down if else, if else, if else, if else. There's a simpler way of doing it, and that is a new statement in C language, which is called as a switch. Now, in normal daily life, whenever you are going to turn on any switch or turn off any switch, in normal daily life, whenever you enter a room, you have just an on-off switch. But normally, if you remember it, a switch can be having many multiple positions over there. Let's like a dimmer, supposedly. You have nowadays dimmer is a continuous form, but previously back 10, 20 years back, the dimmers was having a digital type of a discrete type of a control, which means that you were only having like 5 or 6 different speeds over there, and that would fixed. Nowadays you have that dimmer position analog. You can have any value, maybe just like a slide 1 degree 2 degree variation over there, but nowadays, but previous past, there were just like 5 or 6 different positions. So similarly in C language, you have a switch statement that you will do it on one variable. Of course, that variable has to be always integer character, not float. Remember, not float. This cannot be used for float because this is for exactly values. Float values can have some preceding or trailing zeros over there. So that is never used for float. Only for integers and characters this is used over there, or maybe for boolean or something. So what has happened, again using braces for the start, just like any for loop or while loop, you have case. The word is case because now you are going to call it a case over there. So there is one case, there's two case, three case. So this value grade is a character. It's a character, it's an ASCII character. And if this is equal to A inside those single call quotes over there, then what will happen? A count will be incremented. If B is there, then plus B count will be incremented. If C is there, then C count will be pre-incremented, or you can call it post-incremented over there. And after every statement of this, there is a break. Now, what does this break do? Break actually tells the code that, okay, wherever you are inside these braces over there, these braces, which are starting from the switch statement, if case A is true, you have incremented A count, then break it. So again, if this is true, statement will be broken and you will go after the switch statement. So nothing else will be executed over there. So if case A is true, A count will be incremented and break will be initiated. Break means break this loop, which is, or break this braces or whatever you are doing over there, it will break that set of command. So if supposedly A is not true, okay, no, B is not true, no, okay, no problem. C is true, supposedly, then what will happen? Plus plus C count, which means post increment of C count variable and break, which means afterwards this thing, this thing, this thing will never work. But supposingly, if A, B, C, D, E, so E is not there, F is there. So all of these five are still not true. What happens? Then there is a default one, which means nothing is true, then printf invalid. So if any student has a grade A, B, C, D, E, or E is not there, D and F, then of course this means this is invalid. He has actually entered G, maybe X, maybe Y, maybe Z, or something like that. So this is an invalid, and then it will be printing F invalid statement on the screen for the user. So this is the break over there. So now this is something very important. Let's see this example over there. I have an example over here for this thing. Uh, Actually, I think so. I have an example. It should be here. Should be here, I guess. If it is not here, okay, no problem. Maybe there is something. No, there is no example over here. Anyway, let's just go back and let's just make me an expression. Exactly, I guess I've already told you about the structure. I will just copy this statement here just now. I will make this switch statement over here. Now, structure of switch statement, I've already told you. The expression is evaluated here inside the braces over there, the braces over there. Then case, whatever that value. If it is a character, it has to be inside a single quotes. Then statements over there, how many you are going to have statements, 1 2 3 4, and then the break, and of course the semicolon is always a must. Remember, semicolon is always a must. And whenever you were to use case, the value, then colon, this colon actually tells you, okay, you are going to have 1 2 3 4 statements over there. Then very important, you have to always have the break. If you're not going to put the break statement, what will happen? First of all, this will be evaluated. If this is true, it will go on case 2, value 2. If that is also true by chance, for example, then this will run all these statements, and it will also print your default statement. That is, if none of the case is true, then it will still print the default statement as well. So break after every case is a must, because you are actually going to tell it, okay, this statement is true up till this point. You don't need to go anywhere further. The rest of the statements are irrelevant. So the expression over here that is actually on the very top, that is actually going to be, you are going to make your expression equal to 1 2 3 4 5 different values over there. So the possible values to compare against are this, and break statement, you have to exit the switch. That is important. This is very important. Do not miss this break statement over there. Default, what to do if no case matches? As I told you, if none of these case matches as shown over there, so this one, this one, this one, A, B, C, D, F, none of this works, then of course the default statement will be run, and that is invalid, will be printed over there after the break. Now complete code over there. Let me just see this code over there. What is happening over there? I guess this should be there. I guess this should be complete switch. I guess this is there somewhere. Yes, I have a statement. Okay, I have this one. Let's see this code. What happens? I have the variable. The example is already there, so I don't need to write down the switch statement code over there. I have 5 variables over there. I guess 5 variables. Yes, I have A count, I have B count, I have C count, I have D count, I have E count. So what is happening? I have A count, B count, C count over there, and I have puts the statement. Now you are using it for without any injecting of any commands over there. So it will automatically put that \n, enter the letter grades. So it's asking the user that actually enter the letter grades, enter the EUF character to end the input. So end of over there. So you are actually going to head end of file key sequence. So what is going to happen? You have a variable called as int grade equal to 0. That is one grade over there. So this is actually just grade equal to 0. And this will loop up till, now this will over here, you have while loop, and inside this while loop, now this is something very important. This is actually taking it from the other slides as well. I will just come to it later on. Supposingly, what is happening inside, you can see over here inside the statement, what is happening? Int grade is equal to get character. Grade is equal to get character. Okay, grade is an integer, but inside grade you are putting a function, and that function is taking get character brackets, and inside it this has to be some character. Now how this is working, what is get character? For that purpose, let me just go on back on the slides over there, because that will be available. I will come back to this one. Get character is again on this slide. Let's just see over there. What does this do? Get character is a function. Character, as the name specified, it's a character. So it's going to a function that reads one character from the keyboard. So if you are going to enter A, B, C, D, E, F, G, whatever, that's going to take one character, wait for the user to type one character, returns the character as an integer. This is something very important. This is going to return the character as an integer. So, and then what is EUF? EUF stands enters the end of file signal, which means that, okay, you have had previously, if you remember in the last lecture, we used the sentinel character -1 over there. Now this time, because you are taking an input character, so in end of file signal, how you're going to tell it, that will be on Windows, that will be control plus Z. End of file signal, control plus Z. This is something very important. I will come back to it later on when we'll be discussing the ASCII codes later on in the online class. But here, end of file signal is control plus Z. And if you are on macOS, just like I am over there, then I will have to press control, or actually the control plus D over there. This tells the program I am done entering the data. So now what is happening over there? Let me just go back on the code. This is actually going to tell or take a character A, B, C, D, and if that is not equal to EOF, remember, if that is not equal to the end of file. Now, end of file EOF is a common word inside C language, which is actually telling you, okay, this is, I have pressed now control plus D. If you are on Windows, then you have pressed control plus Z. Remember, for Windows and Mac, there's a little difference over there since I am on Mac at present. So this will be control plus D. So what will happen? It will so this while loop will only work if I have not entered a end of file character. So what will happen? Now what happens inside this switch statement? Now just let me maybe little bit over there. Let's see switch statement. Now what is happening? Switch in brackets I have grade. So I'm just evaluating the value which I've entered. So if I have entered case A, so what will happen? Case A, either capital, either small. Both will be, when both are there, I will increment plus A count. So there is variable A count and I am incrementing it and then break it. So if the value entered was A, small or capital, no matter, this will increment it and break this switch statement. So it will again just go out of this one and then again take the while loop. So inside the while loop, there is a switch statement. So this while loop is actually now taking one after another one over there. And then same thing is being done for capital B, small b, capital C, small c, capital D, small d, and then F over there, which is for the F count. Of course, there's an F grade over there. And then afterwards, if there is \n, ignore the new lines, which is \tab, which is also an escape character, or an empty space. You have to ignore all these three and break it. So for all these three options, because the user can enter anything, user can enter a \n, user can enter just press T, you can just press space. So all these will be ignored and you will just go on the next input. But if all of these are not there, and supposing you have entered E, you have entered F, you have entered G, H, I, J, anything value, then you will print F, incorrect letter grade entered, puts enter a new grade. So it's always asking, or it's always telling you that, okay, enter a new grade, and this will again go back on this thing and again take an input and wait for the end of file character, which is control plus Z for Windows and control plus or command plus D for macOS. And then when this end of file character will be printed, or I will be pressing control plus D, then puts total number of each letter grade R. So it will tell me, okay, how many students have got A, B, C, D, F over there. Now let's just run this code and see how this works. So I will just increase it over there because I'm now every time going to run this one. So when this run, okay, I have a I hope this is not an error. Uh, okay, again, that was, so enter the letter grades, enter the EUF character to end input. So it's now asking me, so let's say I just enter, and turning on my caps lock. My caps lock is now on. Press A, enter. Again, it's taking me input. It's not going to print anything. At the back end, it's doing all the calculation because I have pressed B. Sorry, I have pressed A. So that's why A count was incremented. Then I press B, nothing happens. So every time I'm pressing a character, let's say I put U now, A and B was done, U is there, and I press enter. So you can see now it's telling me, okay, incorrect letter grade, enter a new grade. This was not legible. It is not a part of anywhere. Let's say I press P now. Again, it will tell me, okay, it's not right. Let's say I turn off the caps lock, and now this time I select F over there. Nothing happens because now this is taking that input. So every time I'm pressing enter over there, it's taking the input and incrementing all those 5 variables, which are A count, B count, C count, D count, and F count. So let's say I do it for C also, I do it for D also, and now putting small letters, you can have the caps lock on. And now supposing, let's say I put it E, again, this would be incorrect letter grade, enter a new grade is asking me. Okay, I put an F over there as well. I put another F over there. So I have now added 3 F over there. Let's say I put another A, and I have now put a lot amount of values. Now, how many values I have put up till now? Let's see. I have put 1, 2 legible values. I'm talking about A, B, 1, 2, not legible, 3, 4, 5, 6, 6, not sorry, 5, 6, 7, 8. Now, at this point over there, let's see, I want to do it by control D over there. So let's say I put a control D and that's gone. So I put control D on my MacBook keyboard. So now it has printed it. So you can see the control D, I have put it over there. Control D is that the epsilon point over there. So total for each letter grades are how many A was there? 2. B were 1, C were 1, D was 1, F was 3. And this is exactly the same thing which we entered, and this was printed over there. So this is a new thing for you. What you are doing over there, you are taking a character from this function, which is called as get character. This is a part of the stdio.h, and this get character is taking that value inside the grade, and that grade is an integer. Remember that grade is an integer, but it is taking a character inside it. How? Because this is taking an ASCII character, converting it into an integer value and storing it inside every integer. Let me just give you what I'm actually talking about here there. Let's say I am on, let me just open some Google for you. And I want to actually show you the ASCII table. So what I'm actually trying to tell you, the ASCII table, let me just open some images for you. And let me just maybe open some good size image so I can actually move it up a little. I guess which one is a little bit more. Okay, let's see. So, okay, let's see this thing. You have this table in front of you. You can see over there. I guess this is still not visible. Okay, anyway, you can see over there. In fact, it does not all the values. I mean all the values over there. Okay, let's see this thing. So you can see now what is in this table. If I can open this table a little, maybe if this can open, I can show you in zoom in function over there. That will be much easier for me, because whenever a character is being entered, its value as an integer is being stored inside that integer. So over here, now let's see what is happening. I have a 7-bit ASCII character over there. It can be 8-bit also, but anyway, when I'm doing it, I'm pressing, let's say I'm scrolling down over there, A. What is A? A in decimals is 65. Why decimal? Because this is the decimal value. I can call it an octal, hexa, and binary. Now, you're already familiar with this from your AICT course over there. But again, since I'm entering A, so it will be 65 stored in that. It's an integer. So 65 value will be stored. If I enter B, that will be 66. If I enter C, that will be 67. So whenever I'm entering any value over there, this is the code stored inside that integer. So that's why this variable of grade is an integer. And whenever you are taking that integer, that is storing that decimal value of that character. So ASCII value is being stored over there. Remember, this is not character over there. This is the get character. It returns that function or that character ASCII decimal value over there, which is being stored over there inside this one. So if you are entering P, you are entering N, whatever, you are actually storing that. And whenever you are comparing it inside the switch statement, you are actually comparing it to A. So you're going to compare with small a or capital A. And I guess if I've shown you the capital A's as well, the small a's are also there. So you can have the small a also, that is equal to 97. If you have small b, that is 98. If you have small c, that is equal to 99, and so on. You can have a lot amount of values up till, and these are up till 127, just for 128 values over there. But these are a lot amount of values over there in this one. So these are all some ASCII characters over there, which are being input over there on this file when you are running this file. And this is a while loop, and a switch statement is inside this one. So this is exactly the same thing. Let me just go back on the slides. And this is exactly the same thing over there in this one, which I've done over here in this example over there. Please run this example, do some changes, maybe add A, B, C, maybe add A plus. No, A plus cannot be added over there. Why? Because it's only going to take a character. Remember, this is only going to take one character. That's why get character. Character is just one value over there. So it's not possible to take A plus B. For that purpose, you will have to use if else statements over there or some string comparisons over there. That's a totally different thing. I will come back to later on when we're talking about functions over there. But if you are just going to have, let's increase it to like A, B, C, D. If you want to add B, E, F, G, H, so add those and elaborate this example a little bit more, and then see how many letter grades are there in this example. Kindly do this one, spend some time on this example. This will be much beneficial because this is the switch statement over there, and this the get character is a function over there that is actually being run over there, and you are having this get character returning the ASCII decimal value of that character which is being entered by the user on that keyboard. Then, of course, the exact same thing I've already told you, you can use multiple cases over there, which is exactly the same you have used for capital A, small a, same thing, capital B, small b, same thing, or this is backslash n, backslash t, or space. You can use it, and that's actually breaks the statement. You can just use it for only one, totally up to you. So this will be if grade is A, only A count increases, the remaining it breaks on over there. And then the default case, you already are familiar. I told you that default case runs when none of the cases are run over there, and then it prints it and breaks it. So if any of these cases are not going to run, then the default case runs, it's going to print it. In our case, it was printing the value, it was printing that incorrect letter grade has been entered because this is nothing as compared to the previous one. So you are asked that enter a new grade over there, and then again a break statement. So optional, but again, this is optional because this is the last statement. This break is optional, and this will exit switch anyway. So this will again go back up and again go on, because now switch statement is not a loop statement. Remember, this switch from here till here is not a loop, it only goes once. But since this all has been inside a while loop, which is always taking a get character invokes scanf always. So it's asked the user to actually enter something A, B, C, whatever the character may be, and then it takes on. So this switch statement is repeated again and again inside that while loop over there. So coming back to this one, or the default case, I've already told you, you can use this. The default case executes when none of the other cases match, as I've already told you. Now, one thing very, very important, switch can only be used for integer and character, as I've told you. It is not used for floating point numbers or double, and not also for strings. Why? Because in floating point numbers, you have trailing zeros and one. Because if you have supposedly a temperature of 26.34, now you are seeing it 26.34, but maybe in the database or inside the RAM or inside the memory, this is 26.3400000001. So that one is always there because it's having a precision of maybe like 20 digits after decimal digits. So that's why you cannot compare inside switch statements. Switch statements are used when you have the exact value over there, and that is only possible if you have a character value or an integer value that is always having no decimal part. So if you are switching, you are using switch statement for an integer value or maybe for a character, just single character as you have used in this example, then this is valid. But if you are using it for a decimal, this will give you always an error over there, and it will not be running. And similarly, you can't use it for your strings as well, that is also not. So for that purpose, if you want to compare strings, for that purpose there is some functions available. We will come back when the next chapter comes on, when we will be talking about. And then when we have done the next chapter, or we have started the next chapter, a whole lot of families will be available for you of functions, and I will give you on w3schools.com that how that thing can actually work. Then next thing after this switch statement, please, I will give you some examples in the online class. I will give you some tasks for the switch statement, because switch statement is not that much discussed in this book. So I will give you a little bit, two, three examples to do it yourself, so that you have a practice about the switch statement over there. Then since switch statement and if else, they both do exactly the same thing work. But remember, in switch statement, you are only testing one variable. In if else, you can have many variables tested by using the and or logical operators over there, which are going to come just now after these 2 3 slides. So this is very important that if you are using just one variable, then you can use the switch statement, and you can use it for only integers or characters, as already told you in the last slide. But for if else statement, you can use it for floating point comparisons as well. So if you want a very cleaner, more readable code, then switch statement is good. If you want to do string comparisons, as I've already told you, then you can use the if else statement as example shown. If age is greater than or equal to 18, if temperature is greater than 100.5. Now supposedly if temperature is supposedly 100.5, now this may or may not be greater than. Why? Because you're giving a constant value of 100.5. This is a constant value. And in temperature variable, supposedly the value stored is 100.50000001. So this may or may not. But again, this precision is not that regard, because the temperature, when it is going to come in your value, maybe zero point 0.5 precision is not going to be that much important. So it may or may not run depending upon it. So that's why you're always going to use if else statement for this floating point comparison. But if you are going to talk about letter grades or simple characters or simple day of week 1 to 7 and any character values, characters are not just A, B, C, D. It can be 1, 2, 3. It can be some escape characters as shown in this link I have shown you on this ASCII table. It can be anything. It can be a dollar sign, it can be a number symbol, it can be exclamation mark or double quotes or ampersand sign or single quote. It can be anything. So don't worry, characters can be anything from over here. And ASCII table has 128 if it's a 7-bit, and it has 256 characters inside it. I'm talking about the 8-bit correct ASCII character set over there. So if I want an 8-bit, let me just show you. So if I want an 8-bit ASCII character set, I guess this is available here. So this is that ASCII over here, binary octal hexel, and you can see from 0 if this is available to you. And this again, this is 128. I want a 256 one. So let's see. I can't find it out over here. I guess maybe somewhat here. Again, this is 8-bit. This should be here somewhere. I guess this is one. Oh, okay. So again, this is also 128. I want ASCII table 256 values, 256 characters. So I guess the Google is not giving me that answer over there. So you can have the ASCII table here. So you can see now again in this table, again, this is 127. I guess the remaining ones are not printed over here. I guess I will try to find it out and maybe give it on the website or maybe over there. But they are 100 and sorry 256 available for you. But normally the first ASCII table that was used for the computers in 1970s or 80s, before that even, was actually this 128 from 0 to 127, which means 128 characters were there that were actually used over there at that time. That's why normally whenever you are searching it, it's actually ASCII always having those 128 characters over there. Then coming on another type of statement, which is just a little change from the while loop. We have already done the while loop in the last lecture. Here I'm introducing do while loop. Now this is just a little difference from the while loop. In while loop, what was happening? You had a statement and that statement was being evaluated, or condition was being evaluated, and then afterwards the inside statements were being run. So if condition is satisfied, then this will be run. Otherwise, if condition is not satisfied, this line number 3 and line number 4 will never be run. But in a do while loop, what happens? A little change in the syntax. You start with a do word, again braces for all the commands which are inside it, third and fourth over there. So what will happen? This will run line number 3 and 4 first, and at line number 5, it will now evaluate that, okay, counter is less than 5. If not, then it will go on further. If counter is less than 5, then it will go back to 2, do 3 and 4, and then continue to go on. So what is the difference? Difference is this, that this do while loop will run once, even if the condition is not true. I'm again repeating, do while loop will run only once if the condition is not true. But here inside while loop over here, the condition will only run if this, or sorry, the inside body of the while loop will only be run if this condition is true, then it will run. If it is not true, then line number 3 and line number 4 will never run. So if you want the condition to run once, and then afterwards, if the condition is still not true, okay, then go on for line number 6 and line number 7 or whatever the else program does, you can do it. Then you use the do while loop. So there is not much change in while loop and do loop. The only thing added is the exact word do. There is a reserved word do over here, and then it runs this line number 3 and line number 4 over there. If the condition is still not true, it will still run. So a while loop tests the condition before running the body of the loop. Do while loop only runs after running the body. So it runs once, then checks, okay, not, sorry, that's wrong. So result, do while loop always runs at least once. So it will always run once before testing the condition. So introducing this do while loop is a little difference from the while loop. And the syntax, I have already told you that you have to use after the while condition, semicolon after this one is required. Previously, there was no semicolon required inside the while loop, but here you have to add the while loop or semicolon after the while loop over here as the condition. The semicolon after the while loop condition is required for this do while loop. This is a little difference from the while loop because there is a do statement and there is no semicolon over here on this one. So this is different from the regular while loops. So over here in this statement, what will happen? Counter is equal to 1. So it will print counter 1 over there, and then it will plus plus counter. So this will be, it will be pre-incrementing first. It will be pre-incrementing counter. So counter will be now be 2. So 2 will be less than equal to 5. Yes, true. Then again it will go on, print again 2. Then it will again go to 3, again 3, again 4, again 5. So this time this will be run 5 times over there before exiting this loop. Because after 5, when 5 will be printed, this will become 6. 6 is less than or equal to 5. No, so that's not true. So the answer of this code or this snippet over here, or this snippet of 3 4 lines, is going to print 1 2 3 4 5 in one sequence line over there. So I hope this do while loop is very important over there. But again, remember, you have to use the do while loop when you want the loop to run at least once. You want the loop to run once over there and then ask for an input from the user, again as shown in this example. So if you have a printf statement, you are actually just printing the menu over there supposedly. So you are actually telling the user, okay, if you want to add, then press 1. If you want to subtract, press 2. If you want to exit, press 3. If you want to enter a choice, then scanf and choice. So you are actually asking, you want to do 1 2 3 over there, and for exit, yeah, so you're asking it, if you want to add two numbers, then do 1. If you want to subtract, so this all will be printed first, and then afterwards it is going to ask you after the scanf that if choice, that is a variable over there, that is an integer, if it is less than 1 or choice is greater than 3, then it is going to print invalid, try again. So this statement is actually going to tell you, okay, try again. So this means that it is actually not right. Then afterwards, this loop will run still while choice is not equal to 3, which means this loop will always keep on running again and again up till the value 3 is there, because this will choice not equal to 3, which means whatever is inside this variable choice, this will be tested for this equation. So if choice is having a value 1, yes, this is not equal to 3, true, again it will go back to line number 3. If it has 2 entered, still not true, or sorry, is still not true, it will again go back to line number 3. Again, if it is 3, then yes, now this 3 is still not invalid, but now this is false. So now this will exit this do while loop over there and go on the line number 14 over there, which is being any other command or anything over there. So you have to use the do while loop when you want the loop to run at least once over there. So if you want to run the do while loop once, then you have to print it over there. So there's a slight difference between a while loop and do loop, as I have told you. Just a little tabular form description of the comparison. So while loop tests the condition before the body. Do while loop does not do this condition, or does it after the body is executed one time. So it always executes one time. Minimum executions for a while loop is 0. If condition is false, while loop will never run, because the condition is on the top of the loop over there, that is the while loop over there. Semicolon after the condition, no, because in while loop you are not going to put any semicolon, but in do while loop, yes, it's required. then it is best for unknown number of iterations, because you don't know how many iterations you want to do. Then you have to use the while loop, because you are always taking some input, doing some stuff over there inside the body of the loop. But if you have to have some menu or validation, then of course you have to use the do while loop as shown over here in this example, because you are printing add, subtract, exit, and maybe you have, like, you have add, subtract, multiply, divide, and you are doing something over there. So you can use this do while loop over there if you want to have it over there. Example comparison can be get a positive number from the user. So this will continue to go on, ask at least once, repeat if invalid. So with while would need to ask once before the loop duplicated code, which means if you want to ask something, so before the while loop, you will have to ask over there, okay, give me a scanf. So this will be a scanf command before the while loop if you are using the while loop. But if you are using a do while loop, the loop body will be run once, take the input, evaluate the condition at the very end, and then go on further. So do while loop is something good for menus and validation whenever you want to do it. And coming back to the break statement, which was over there, break statement is not just specific for your switch statement. It can be used anywhere inside any loop. And what it does, it breaks that loop. It breaks that whatever is being done inside that braces over there. So if I'm doing this break, what will happen? If x is equal to 5 and this is break, whatever is inside this braces from this for loop, this will be broken. So what will happen? What I want to do this in this code over there, if you can see, for int x is equal to 1. So x is equal to 1, x is less than or equal to 10. So what it should do? It should now go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this means 10 times this should loop should run, and this should printf over there. But when x will be equal to 5, there is a condition inside it between line number 3 and 5 over there. It will break the loop. So it will only run up till 1, 2, 3, 4, 5. So it will go to line number 8, and this will be broke out at x equal to 5. So loop stops immediately when break executes over there. So the control jumps to the first statement after the loop over there. So works in the while loop, for loop, do while loop, and switch statement. So break is not specific for just the switch statement. It breaks any sequence of commands inside the braces. The braces are these curly brackets over there, which I'm using it over there. So this break statement can break the loop inside for loop, while loop, do while loop, or switch statement very easily. I guess there is one example as well over there. Let me just give that example a little point over there. Maybe it's somewhat here. You can see over there what is happening over there. I have a variable x equal to 5. Same thing. I have already declared it, semicolon, x less than equal to 10 plus plus x. If x is equal to 5, break it. So what will happen now? Let me just run this one, the same statement. So when I will run this one, let's just say, so what will happen? You can see 1, 2, 3, 4. It should have run to 5, 6, 7, 8, 9, 10. But again, why? Because I have written f is equal to 5. That's why it breaks the loop only if x is equal to 5. Let's say I want to make it 8. Let's say I have made it 8. Now what will happen? Uh, now what will happen? I guess I will change the comments as well. So what will happen now? You can see 1, 2, 3, 4, 5, 6, 7. At 8, it breaks the loop. So it will never print that eighth number, and it will reach line number 18. So it has broken out, actually broken on it. It should be broken out of the loop at x equal to 8 over there. So this is actually breaking the loop at x equal to whatever value you have specified over there. So break statement is something very, very important, and it's used a lot in many of the loops, because if you don't want to find a specific number, for example, now this is something a little difficult, and uh, over here, I will not prefer not to discuss this example, because up till now we have not discussed arrays up till now. So I will leave this slide number 36 at present, because this is the description of an array. Now array is something like a structure in which data is stored, and that data can be integer, it can be string, it can be something. And how to describe an array is just like a matrix over there, and I will come back to it later on. Maybe in the online class, I will discuss this array first, and then we will discuss it. And you can remind me when we'll discuss this 36 slide at that point. But just a point over here is it that when this break statement works, the for loop statement will be broken. So whatever the value of I, whatever, it will be broken. So this is just like a statement. So you have found out some value or something, so it will break out that loop wherever it was, and it has found out the statement. Then thing opposite of break. What does continue statement do? Continue means that it skips the rest of the current iteration and starts the next one. So what this does do? If same thing, same command for int x equal to 1, same up till 10 it should work. If x is equal to 5, previously there was written break. So what is now going to happen? This is going to continue, which means all the commands inside the for loop will be skipped and it will go up over there. So let's say I will just give you an example over there. Let me just go on the code. Here, instead of break, I write down continue. So what happens? Let me just take it. Continue. Now what happens? Okay. So what will happen? Now this will not be printed. Let's just say this is not printed. What will happen? This for loop will run 1 to 10 because the initial value is 1, the condition is 10, and this will continue to go on up till the printf statement. This will continue 1, 2, 3, 4, 5, 6, 7. But when 8 will come, this will go on to the start of the loop again and skip everything which is below that line over there. Let's see how this works. Right over there, I guess again that AI is coming in. Let me just run it again. I have to actually put that cursor somewhere. So now what you have done over there, let's see over there what is done. 1, 2, 3, 4, 5, 6, 7, 8 is missing. Why? Because the condition was if x is equal to 8, continue. This skips anything below it. So even if I have something over there, that will be skipped over there. So if this condition is true, let's say I make this condition equal to 4. So when I do this thing, you can see now 1, 2, 3, 4 is skipped. So this is something very good. If you want to, if you have found some value, you have done something and you want to skip that, whatever is being done below, you can use the word continue. This word continue makes anything below it for that particular iteration skipped. It will be skipped over there totally and it will go back to the start of the body of that loop or for loop or while loop or do while loop or whatever it can be done over there. So break and continue, they works opposite to each other, but in a different way with each other. So it skips the remaining code in the body loop and goes indirectly to the next iteration. So whatever is below that, it will be skipped and it will just go on over there. So it will be for loop, it will increment happens, the condition is tested. For while loop and do loop, condition is tested immediately over there. So it will for loop, the condition is tested, and for while loop and do loop, the condition is tested immediately. I guess that's already over there. So you can use this continue number for skipping even numbers. Very simple example. You can see where you over here, you are having odd numbers from 1 to 10. And what you are doing over there, you are going to skip whenever the value from 1 to 10, that is for I value from 1 to 10. So if this is 1 divided by 2, equal to 0, which means if it is going to be an odd number, then this condition is false. So this will not go. But if it is a even number, let's say if it is 2, I is equal to 2, then 2 remainder 2 of course is going to be 0. If it is going to be 4, 4 remainder 2 always also going to be 0, because all even numbers when divided by 2, they always give a remainder of 0. So what will happen whenever there is an even number over there, it will be skipped because there is a continuous statement. So what will happen? It will not print anything. But if it is an odd number, this condition will not be true. So it will be always printing percentage d I. So it will always be printing that decimal value of I, and that is 1, 3, 5, 7, 9. So what will be the output? 1, 3, 5, 7, 9 will be printed over there. So in this way, you can skip or you can break the loop by using the break command, or you can use the continue to skip that iteration, that particular iteration, which is working over there very easily over there. So just to summarize how this break and continue works, the break versus continue works over there. Breaks exit the loops completely instantly over there. Wherever it is, breaks it. Continue only skips that iteration which is working and skips all those commands which are working over there. So what happens next in break? Jumps to the statement after the loop. So whatever loop you are working, for loop, while loop, do while loop, so that jumps to the end of the loop as you have seen over there. If you have a continue statement, that jumps to the loop update or test. So if you have a for loop, it will go on to the top of it, test it. If you have a do while loop, then of course it will go on to the last point over there, test it, and then go back over there. So where to use all of these? Break statement works, found what we need. So if you are trying to search something, you can use break. So if inside a loop you were trying to find something, you've got it, okay, remain, rest of them, skip it, use the break statement. Continue can be used where you want to skip some certain values, as you have done in this example. You wanted to skip the even numbers. So you have a condition over there that if I is remainder 2 not sorry is equal to 0, then you are skipping the even numbers. So you have the over here. So loop ends, yes, break statement always ends the loop. Whatever, wherever the value of the control variable is, it breaks the loop over there. Continue, loop continues that specific iteration. Any commands below that continue statement, they are over there. So visual comparison, just to give you idea, break stops the loop entirely. As I already told you, anything, wherever that value, whatever the control variable, wherever it is, it stops the loop entirely. If you have a continue statement, skips this one, but keep going over there. So it skips that particular iteration, whatever commands are below that statement, they are skipped, but it keeps on going over there. This is something very important. You have to practice these two a lot inside your code. That will be beneficial for you, and hopefully in the online class we can go on over there. Then we have the logical operators. I guess this is all enough for today, and maybe in the next part I will discuss this logical operators. Meanwhile, all of you are familiar with your and or not gates. You have already done it in your FSC or A levels over there. So we'll be discussing this and or and not, which are replaced by this and symbol or not symbol. And again, they are used inside your if else statement. Up till now, you have been dealing with integers up till now. Now this time you are going to see that if you are going to have two variables being conditions being set. So if you want your age to be greater than or equal to 21 and has a license. So if supposedly I want to award a grade in this class to a student, so I have to first of all check, okay, that student has 90 plus marks. Okay, this means A grade and his attendance is also good, then I am going to award it. If attendance is not good, then I'm not going to award that grade, and that will be WF grade over there, because that student is not entitled to get a grade from this course. So attendance and the marks, they both are important. So then that will be a and operator. We will discuss this later on in the next part over there. So we'll discuss this logical operators and operators or operators over there, and the not operator also in detail. And then we will discuss some uh, problems which are in C language, and this is the precedence table over there. And then we will give a little small introduction to the chapter number 5, which is the functions over there. And that functions we will discuss in detail, how what is a function, how that is done. That will be the next part, hopefully. But that will be all for this part, and hopefully you have got. Please try to do these examples in this part over there, which I've done over there, this continue statement, or if you want to do this one, the break statement or the continue statement, wherever you want to use it, you can try to understand these examples. I hope this is all for today. Thank you.